Before solving this question from JEST 2024, let us discuss a concept which we can use later to solve this problem. Expectation value of position operator, this is equal to x naught if psi, the wave function, is symmetric or anti-symmetric about x naught. You may not see this as a boxed theorem in Griffiths or Zetley's book, but you can use it. This is provable. I will give you some examples to make this concept concrete. In the case of a harmonic oscillator, the ground state wave function psi naught in harmonic oscillator n starts from 0, n equal to 0 is ground state, psi 0 is symmetric about x equal to 0, and when you find the expectation value of position operator with respect to ground state, you see that it is coming out to be 0. Psi 1, which is the first excited state of harmonic oscillator, is psi 1, which is first excited state, is anti-symmetric about x equal to 0, and when you find the position operator expectation value with respect to first excited state, it is coming out to be equal to 0. Another example that we have is in the case of a particle in an infinite potential well which is asymmetric. Asymmetric means that it extends from x equal to 0 to x equal to L. The ground state wave function is this psi 1. Here n starts from 1 and then goes on. So psi 1 is the ground state of particle in infinite potential well. This is symmetric about x equal to L by 2. So this point is L by 2, x equal to L by 2. Now this is first excited state psi 2. You can see that it is anti-symmetric about x equal to L by 2. When you find the expectation value of x with respect to ground state, it is L by 2, and when you find the expectation value with respect to the first excited state, that is also L by 2, which means this is correct. The expectation value of position operator is equal to x naught if psi is symmetric or anti-symmetric about x naught. Now we are going to apply this in the given problem. We have psi of x equal to n x ln x plus 1 minus x ln of 1 minus x. So the wave function given is psi is equal to n, this is normalization constant, and then we have x ln x plus 1 minus x ln of 1 minus x. Now you can see that psi of x is equal to psi of 1 minus x. We see that psi of 0.25 is equal to psi of 0.75. Psi of 0.10 is equal to psi of 0.90. What I am trying to say is psi is symmetric about x equal to 1 by 2. Therefore, expectation value of x will be equal to 1 by 2. We are given the expectation value is equal to 1 by n, and we have to find the value of n. The value of n is 2.